Hello folks, good to see you guys back at the channel. Today is the day when we finally do a hard problem because it's been a while since we have done one of these. We always keep doing these easy problems. So let's see, why is it really hard or is it just a mischaracterization of the problem? But we will soon find it out. But here we are doing a trapping rainwater problem. It's saying given n non-negative integers representing an elevation map where the width of each bar is 1, compute how much water it can trap after raining. And this is the example he gives you, and then the output is saying is 6. And black is the height of uh, the, basically the elevation map is what is represented by these black dots. So that's at that particular index, that's the height. At that particular index, this is the height. And the blue is the water that is trapped. So same thing over here is saying height is this and the output is 9. So 6 units of rainwater are being trapped. And I guess the idea is, if you see, how can the water be trapped and how much water can be trapped. So if you are sitting at a particular, if you are standing at a particular index and you look to its left and look at the maximum height and it's on the left, and then you look at the maximum height on your right, you take the minimum of those right max and left max and you subtract it from the height of the current node. That's the amount of water that can be trapped. So with that approach, let's try to do this problem. We will need a variable to hold our accumulator kind of thing, where we will be storing how much water can be stored, and then we would need two variables, which is right max and left max, and then we would also need two arrays, which is right heights, and let's do a malloc right away here. Size of in times the height size here. So that's our array to hold the max height on its right, and then we will have a left heights, and then same thing over here. So let's build these arrays first before we can start the actual calculation of calculating the total water trap. So what should be our approach? So just imagine you're standing at the point 0 here, looking to your right, and as you walk, as you go towards the right, you capture the maximum height. And if it is lower than that, you don't reset. The only time you reset is when you see a node which is higher than the last that you had seen, and that's the concept of the right heights. So we're going to do like this, which is, we will walk the whole range of the array that is given to us, and then we would say, what we would do is we say if we see that height, by the way, it's not heights, the input array is actually known as height. If height I is greater than right max that we have seen so far, right max, then we just have found our right max is reset to height I, right? And here we just do a right heights I equal to right max. Now here keep track of one thing though, that this is not part of that if loop. So please don't confuse and then you make that mistake. Ideally some people do also this. They always use braces, whether you have one statement or you have multiple statements. So that's our right height. Same thing we're gonna do for the left height. Instead, we just say here this time right max. Okay, so we have not used underscore here. Might as well do it now. So we just change that to. Now one thing is, when we build this one, we are standing at the end and looking to the left. So we have to actually start by having I assigned to height size minus 1, which is the last index, and then changing the condition to basically as long as it is greater than or equal to 0, and here to basically decrement it. Once you do that, then we have this time we have to change to left max, and that's we say left heights equal to left max, right? So there we have both the arrays built. Now all we need to do is we need to do the walk again. Let's copy this thing here, no need to keep typing. Okay, and then what we do is we say that total amount of water, total equal to total plus minimum of the right heights I from that point minus left heights I, and then you subtract from that our current height at that point. Now let's not make any typos. Okay, so here we are. So that's our total, and I hope I do not have to put any more braces if I'm right, because I wonder if you need to do one of these, but probably not. And then we can all simply just do a return total, and that should be our solution. But we haven't implemented min yet, so we have to implement this array min. So we say define min, and that is not very hard. All we need to do is a less than b, ternary operator, then we say a, otherwise we return b. And only thing is that the purist would tell you that you should always have your macro arguments surrounded by brackets, because there can be side effects, even though in our case all we have is numbers. So with that, let's see. Okay, so we have a problem. It's saying that min requires 2 arguments but only 1 given. Did we do that? Okay, yes we did, because we actually are doing. So that was good. Interesting that it caught it. Let's see. Okay, all right. So that test case is passing. Now let's try to submit. Awesome. So that's passing as well. So there you have it, your Leetcode 42, and which is basically trapping rainwater. I see that the time complexity here should be ON, because as you can see here, each of these loops is basically just going once all the way, and there's no loop within a loop. So it's ON, and then the space complexity is also ON. So with that, I wish you all the best in your interview experience, and even if you're not interviewing, I hope if you happen to do these problems just for the intellectual challenge, that's fine too. And with that, I will see you hopefully in the next video, and I wish you all the best. Adios, bye bye.